Hello, everyone. I think we are now in time. So I'll start with the Pandas and SQL tutorial. Let me share my screen. Oh, what happened here? Oh, that's the one. Okay, so I'm Camilo Valenzuela. I'm a software engineer in ALeRCE. And this is a really brief tutorial for Pandas and SQL. It's focused mainly to beginners in Python and beginners with Pandas and SQL. So it has a lot of simple steps, but useful one. So I'll start with Pandas. So I will start with what is Pandas, why, how to
Camilo?
Pandas. Yes?
Can I interrupt? Yeah, so perhaps can we confirm with people that whether they have the link and whether they can open
Oh,
the...
yeah. So Francisco sent the link to your emails. I think it's in the chat also, but if you don't have, please ask in the chat. And I think anyone from the team can send you the link. We're working in collab, so don't worry for resources and any kind of that stuff. So I'll start with Pandas. So what, why, how to Pandas? I'll let the when and where to Pandas for you, but I'll just do the what, why, and how. So what is Pandas? Pandas is a data analysis and data manipulation tool created in Python. The idea of Pandas is to have a good performance. So it's written in C and Python. Has a lot of tools to read and write from and to several common data formats used in data science. For example, CSV, Parquet, Excel, and other kind of formats. And the main focus is tabular data manipulation. So it has a lot of tools to do that. And also one characteristic that is different, for example, for NumPy, is that it has data indexation. And it's really powerful for some kind of queries or some kind of uses. So why we are using Pandas for data analysis in ALeRCE, similar to NumPy and SciPy for linear algebra and AstroPy for astronomy, Panda is now the standard package for data manipulation in data science. So, and it's also becoming, it's getting an ecosystem of tools that is being developed around Pandas. For example, data visualization and machine learning integrations. So I'll start with how to Pandas. First, we will start with the installation. The Pandas package is in the Python package index, PyPy, or most commonly known as the pip repository. So you can install it with pip install Pandas. If you are using Anaconda or any Anaconda distribution, you can install it with conda install Pandas. And if you are running it on Colab or Jupyter Notebook, you can use this statement that is the pip install Pandas with the exclamation mark. So we will run this one and we will have the latest Panda. So to load Pandas, commonly the people are using an alias. So we will import Pandas as PD, the standard alias. And now we will go deep into the Pandas core. So Pandas core is based on two data structures, the Pandas series and the Pandas data frame. A Pandas series is a column in a tabular data. For example, here we have the magnitude. And for each object, we have the magnitude of that object. And a data frame is the represent a multidimensional table from a collection of series. So we have multiple columns, and that we call a data frame. So for example, here we have the magnitude, the error for each object. Also, the series and the data frame is indexed by an index. That index helps us to have a better performance to access the data, to do data manipulation and data visualization. And it's really important that index when you start working with Pandas. So we will start creating a series. So for example, I have here a list of object names, for example, Crab Nebula, Orion Nebula, Andromeda Galaxy, and the Pleiades. And we have three series here. To create a series, we use pd.series with Pandas series, and we pass a list of the values. For example, here we have the Messier values, the apparent magnitude, and the absolute magnitude. This one comes from Wikipedia. I think it doesn't have all the absolute magnitude, so we use here the value from NumPy called nan, not a number, to explicitly say that there is a missing number there. So we run this one. And the first one, the Messier, we see that here is the values of the series, and here is the index. We didn't pass an index explicitly here, so Pandas created a sequential number to use as an index. The apparent magnitude and the absolute magnitude, we here pass the index parameters, so the index here is the name of each object. So we have now three series, and now we want to create a data frame for those series. So to create a data frame from series, I will pass a dictionary with the column name, and the series. So we have the apparent magnitude, the absolute magnitude, and the Messier name. So if we do the pd.data frame, we will have something like this. And here we have a problem because here we have the index of the Messier and the name of each object. That's because the Messier series has a different index than the other series. So Pandas he doesn't try to fix the data frame. It just fills with NaN values. To fix this, for example, we can change the index of the Messier to the names of the objects and create again the data frame. And now we have a good data frame with each object with their apparent magnitude, the absolute magnitude, and the Messier name. So that's one way to create a data frame. There are other ways. For example, we can pass a dictionary where the keys are the columns, and then the values are an array of the same dimension with the values. For example, here we are passing that dictionary and we'll create this data frame, or we can use a list of dictionaries where each key is the column name. So and generate the same result. So that's how we create a Pandas data frame in a Pandas series, or a column and a table in Pandas. But the data always come in a file for our cases. In this example tutorial, we will use a CSV file, but Pandas uses the same syntax for each format. Pandas.read and the name of the format and the parameters. For example, if you want to read an Excel file, you can do pd.read Excel and give the parameters. To read a CSV file, for example, pd read CSV and the data path. We can give the relative path to the file, the absolute path, or an URL. So it's really flexible in that aspect. And if we read the documentation, we can read the documentation of a function using the interrogation sign. We can see here that the read CSV has a lot of parameters. Almost every time you use CSV, you can use the default parameters, but some formats has, for example, instead of a comma, it has a semicolon or something like that. For now, we are using a CSV file that is in our files in our FTP in Amazon. It's called detection.csv, and we are using the index column will be the object ID. So if we load this one, you will see it loaded, but we don't see anything. So now we will start doing data visualization or just viewing the data. So Pandas has a lot of methods to do that. First, we have the head and the tail methods. The head shows the first n rows of the data frame. The tail shows the last n rows. For example, here we have the first 5 rows and the last 5 rows. And we can see that the detection data frame has the object ID as the index. It's in bold here. The count ID, the alert ID that comes in from CTF, the modified Julian date, the filter ID, and other parameters like position, magnitude, and so on. Also, we can use a method called describe to see some statistics for each column. For example, the modified Julian date has this amount of values. We can see the mean, the standard deviation, the mean, the max, and some quantiles. For example, the 25, 50, and 75. And this is really useful to see if the CS file you loaded correctly, and the data, for example, if you are using values from 0 to 5, and there is, for example, a letter, a character in the file, you can see that the mean and variable, this kind of variables doesn't compute because the column there is a string column, not a number column. So also we can get the index. Here we are using the unique method to get the unique indices. And this will show us the object IDs from this CSV file. And we have 100 objects. And these are the objects IDs. They come from CTF. And that's mostly all the data visual accessing, or after we read the CSV file, we can do. Now we want to play with the data. So we want to access the data, do some data manipulation. So I'll start working on data accessing right now. So first we start selecting a column. To select a column, we have two syntaxes. The first one is using a dot and the name of the column, for example, the magnitude PSF. Or we also can use the Python dictionary syntax. We can give the brackets and the name of the column we want. For example, the sigma PSF, that's the error in the magnitude PSF. And here we have, for example, the magnitude and the error. And that's how we go. We get just the series for that column. Now, for example, if we want to filter the big data frame, we just want some columns. We can, instead of giving one column, we can give a list of columns. For example, here we have the magnitude, the error, the Julian date, the modified Julian date, and the filter ID. And if we filter that, we can pass it like a dictionary, but the dictionary here, the key is an array. So if we pass that, we can get a new data frame that only has those columns. It doesn't have all the columns, just 4. If we want to select, for example, one object in a specific, for example, here we want to select this object that is important for me for some reason. We use the location attribute from the data frame and use the same syntax as the dictionary, but we are using the index value here, the object ID. If we do that, we will receive a data frame where the index is the same as the one that we use. For example, this object. And this one will be, for example, the liker for that object. So we will have the magnitude, the error, the time of the alert, and the filter where that magnitude was taken. And also another kind of visualization we can do, Pandas has built-in plotting. So for example, here we are creating 2 plots with matplotlib. In the first one, we are getting the macPSF variable or series, and we are using the histogram method. We are assigning to the first plot, and also the same, but the error for the second plot. And automatically, Pandas will call matplotlib, and it will create the histogram for each series. Now we have the magnitude and the error. And for example, we want to filter some alerts that are important for me. For example, we want bright alerts with small errors. To do that, we first created here a threshold. We want that the macPSF will be less than 17 to have bright alerts. And for the big errors, we want the error that will be greater than 0.25. So we have 2 filters here, and we want to combine them. So we do the big alerts, and we want the alerts with small errors. So we have big errors, and we use this not operation to get the small errors. So our filter mask will have the bright alerts with small errors. So the bright alerts are more than 1,000. The ones that has big errors are 128. And the filter one, adding these 2 filters, are 1,140. So we filter one alert that was having a big error. And to filter the column itself, the data frame itself, we use the same syntax that we use for columns and selecting specific objects. We give this filter that is a Boolean filter to the data frame, and we will receive a data frame with only those alerts. And if we see what the filtered series has, it only has an index, and true or false is if the filter is true or false. That's the only thing that it has. So also we can sort these values by their index. For example, we can sort by here, the index is the object ID, so it's will be sorted by the object ID name. But there are more important ways to to filter this, for example, if you use a sequential number index, maybe you want to sort by when the alert comes. So we can use sort values to specify a column. And in this case, we are sorting by the Julian date, and we will have the data frame sorted. So we can do really easy sorting here. Also, you can do a sort by two columns. For example, here we are sorting by the Julian date and the filter ID. So in that order. So you can use a lot more filters and sortings. And the last part of data accessing, for example, if we have a categorical data, for example, in this case, we have the filter ID that is 1 or 2. We can do filter columns, the number of the name of the series I want, and use valid counts. And in this case, the filter ID, we have three filters. I didn't realize that in the data, but we have 3 filters: the R, the G, and the Y. Yeah, and we have almost the same amount in 1 and 2, and some little alerts in the band number 3. So that's the basic accessing to the data. Now we can do more fun stuff with data frame join, apply, and group by. For example, here we will load another data frame. We have here the periods for each. We calculated the periods using a periodogram. I don't remember the details, but each object has his periods calculated if they are periodic. So we are loading these periods, and here are the periods for each object in our dataset. And we can use the join method to.
Excuse me, Camilo. There are some questions here in the chat.
Yeah.
Please, I'm going to read aloud so we can answer them. Okay. The first one is about from. Let me see. Sorry. Carlos Quesada is asked about, it is recommended to separate data frames and make relations by ID keys. I don't know if Carlos Quesada want to make to talk about further about that. Maybe he's talking about having different data frames and make joins between them.
Yeah, the main idea here when you are doing joins, it's using the same index for each data frame. But if you have a big data frame, the problem there will be more in your resource constraints. For example, the memory that you can use in that machine. But it's not really, if you have a small data set, for example, some thousand records, 40,000 records, and you have, for example, the cross-match in other catalog, and you can do joins, it's better to have a big data frame. But it will depend on the amount of data and resources you have.
Okay, thank you. And another question from Claudio is from a statistic of each column. Is it possible to obtain kurtosis and excuseness?
Okay, so the describe function for Pandas is really simple. So you only can get the count, mean, and some quantiles, but you can use, I will do an apply function in, I think, 1 or 2 more cells. You can use that function to get, for example, kurtosis and other kind of statistics.
But by the way, they also come already programmed in Pandas.
Yeah, it comes in Pandas, but it's not calculated with the scribe. So you can.
Okay. Another earlier question was how to iterate data frames.
Oh, I didn't do that on this tutorial. I focus more on the applied. But if we have time after I finish the SQL part, we can do that.
Okay, thank you very much.
So I was in merge. So if we have two data frames that we have useful information and we have the same ID to do merge, we can do, for example, change the index for the second one and do a join. And after the join, we will have, for example, here we have the magnitude, the error, the Julian date, the filter, and also the period. And now we have both data frames in one big data frame. So what if I want to do something with this data and create, for example, a new column processing each row separately? So for example, here I created a function that calculates the phase. The phase here is the modified Julian date, modulus the period, and then we divided by the period to have something between 0 and 1. So if we want to calculate the phase, we can use the apply function over the data frame. So data frame dot apply, we pass the function we want to apply in each row, and the axis here is 1 because we want to do it in rows. But if you want to do, for example, a function in the columns, you can use axis 0. So we use this, and this will create the phases series. And then we can do detection phases, and this will create a new column called phase, and we will get the phases inside this data frame. So if we run this, we will see that now we have the magnitude, the error, the Julian date, the filter, period, and also the phase. There is here commented a second way to do this, but the idea was to use apply, but you can do it directly with Pandas using an element-wise operation. This is a lot faster because Pandas is programmed in C, so this is like linear algebra in C, but the apply function is really useful when you have something that it's not really easy to do like in a linear algebra way. Okay, so we have now our data frame that has magnitude, error, Julian date, filter, period, and phase. And now I want to, for example, plot this data. For example, for each object ID, I want to plot the liker. So I created here a small function that for each filter, it makes a mask for each filter, then get only the alert for that mask. We sort by Julian date, and then create a scatter plot. The same with the phase, but here we sort by phase. And we are using here the group by function. So and we are passing the index. So for each index, it will create a group and a data frame for that group. For example, the first object ID, and then we will have a data frame with all the detections or all the alerts for that object ID. So if we, and also I added here a random value to plot some of the values. You can remove that and get the 100 like curves, but we can plot this one. Now we have the detections as they come, And then we can see the folded light curve or the detections in phase instead of in time.
Camilo,
Yes?
just a small comment so the experts don't get scared. You're plotting the original magnitudes, not the correct
Oh,
ones.
yeah. It's the original magnitudes, not the corrected ones.
But
So
you have to flip the axis.
yeah, I want, yeah. The magnitude here is the axis is flipped. So it's using the standard plotting, but it's not really in magnitude here. Yeah. So we now have a new data frame that has a lot of data, a lot of new data. For example, has filtered data because I don't care about all the columns. It has data from another data frame, and also has a new column that I calculated that is the phase. So I want to save it. To save a data frame, it has a simple interface. You use data frame dot to and the format. You can use Excel, you can use Pandas, Parquet, Pickle, what you want. In this case, we will save it to a CSV file, detections with period.csv. And because we are working in Colab, we use the Colab file download to download directly on our browser. So if we run this, it saves the data, then says download the data. And if we wait for some time, the data is downloaded. I don't know if you are seeing this, but you can see the data. Oh, like this. So this is how we save data. So for Pandas, you can read data really easily. You can manipulate data really easily. You can do some complex data manipulation like joins, merges, and plotting and other kind of data manipulation. And also, if at the end of the day, you can save all the data really easily in different formats. So that's the Pandas part. Now we will focus on the SQL. So what's the time? So I have some time. So SQL or structured query language is a query language created to interact with relational databases. So in this tutorial, we will focus only on data retrieval, so read-only queries. But you can use SQL to do almost everything to the database. Add records, delete records, update records, everything you want. For this tutorial, we're using SQL Alchemy. It's a high-level package to do connections to relational databases. But there are also some low-level packages like SQL 2, SQLite3, and MySQL. You can check that later. To install SQL Alchemy, you just use pip install SQL Alchemy. And now we are doing the connection to the database. So we will use create engine. And here are the parameters. So I added this disclaimer. We are using a read-only user for the database, and it has a timeout. If you run a query for more than 15 minutes, the database will kill it. So try not to run really big queries. You will not get good results. If you want to run a big query, just ask the teams by an email or something like that, and we will give you a better user for that job. So we will create the connection. Here is the connection string. Here we have the user, the password, the host, the port, and the name of the database. And the engine is created. So now we can start doing queries to the database. So the query to do data retrieval or to get data is the select statement. The select statement may vary from database to database. For example, in Postgres and MySQL, but the base is the same. So you have select the name of the columns you want to retrieve from the table you want to query, where, and here you have conditions. For example, different filters, and you use and or statements to get different results. Then you can use order by, for example, to sort the values by a column, and you can have a limit of the result queries. So we will start with a simple query, and we will use Pandas. Why Pandas? Because you can read directly to a data frame from Pandas. So Pandas has a read SQL that if we see the documentation, you give an SQL statement and the connection, and we will get a data frame. So we will start with a really simple query. So we will select all the columns, that's the asterisk here, from object. We will give a limit of 100. So we use Pandas read SQL, the query here, and the engine. That's the connection. So if we run that, we will have this result. It's a data frame directly from the database. It has 100 rows and 20 columns. In these 20 columns, we have some position values, for example, the mean right ascension, the mean declination, and the error there. So we have some color data, G minus R, max, mean. We have also the corrected one in some cases. Some time variables, for example, the first detection, last detections, and the difference between them. And some detection statistics, for example, the numbers of detection. Now that we did a simple query, we will start doing filters. For example, here we will get all the columns for the table object, where the number of, and we will give the limit of 100. So we pass the query and the connection, and we will get the results. This filter is really easy. If you can have a lot of conditions here, you can start getting, for example.
Camilo, you have less than 10 minutes.
Yeah, sure. Okay, so also you can do data aggregation in the query itself. So for example, here we will have the max Julian date, the first detection, the mean, and the average. If we run that, we will have the aggregated data. So this is the part the most important for me. So we are using a relational database. So relationships in a relational database are made by having a primary key. That's the identifier in the table that identifies unique rows. And how you do a relationship in a relational database is that you have the primary key, and the related table has the primary key of the other table as a parameter in the table. So it's called foreign key. So for example, here in the table object, we have the object ID as the primary key, and the magnitude statistic has the object ID as a field. So the record here can be related to the object in the other table. So that's the main idea on relationships, and then we will start doing joins. So first one, we will do subqueries. For example, we want the information of the object, but we want to filter that object table with the data from the max stats, the magnitude statistics. For example, here is an example. We will want to filter the magnitude statistic where the minimum magnitude is between 15 and 20, and we will get 100 object ID from that. And we then use a select from object where the object ID is inside our first filter. So if we run this one, the SQL statement is select from object where the OID is inside this select here. So this one will return an array. The array will be compared with the OID in the object table, and that's how we do a filter, but we only get 20 columns, the columns from objects. So what if we want to get the columns from objects and max stats? We do a table join. For example, here we have, there are 3 types of joins: inner joins, left joins, and right joins. It will depend of if you want to fill with null, if the values from the other table doesn't exist. But we will focus in the inner join in this tutorial. The inner joins looks for records that exist in both tables from the join. For example, objects and max stat. If it doesn't exist in one, it doesn't show in the result of the query. So we will start with select all the columns from objects, but we will do an inner join with the magnitude statistics on, this is the primary key from the object and the foreign key from the max stat. And this will say to Postgres where to do the join. And here we will filter from the magmin between 15 and 20 and the number of detections from the object greater than 10. If we run this query, we will have a data frame, but now we have 100 rows because we use the limit, but with 40 columns. We will have the columns from objects and also the columns from max stats. That's a better way to get more data. So for example, here we are selecting just one object, and here we can see that these parameters here are for the objects table, and this one are for the magnitude statistic table, and we have for each filter. So that's how to make a join. There is another way to make a join. So I have here the objects table and the probability, and you also can do an implicit join. Do a select, for example, here, and the columns from, and you do a list of columns. For example, here is objects and probability, where here you need to put the primary key from one table and the foreign key for the other table to do the relationship, and you put the other filters. For example, here we are looking for all the objects with their probabilities from the Likert classifier, and it's sorted by their probability. So if we run this, it takes like 5 seconds or 10 seconds, I hope. Okay, so we have the results. We have this one from the table objects, and this one are the probabilities and the classification. So we will use another library called Seaborn. It's a data visualization library, and we will do a pair plot. So we will have here the distribution for each object type. For example, superluminous supernova, eclipsing binaries, AGNs. And we can see that there is no correlation between their first MJD or their first detection or the last detection or the number of detections with their probabilities.
Sorry, Camilo?
Yeah.
The time is already, you are at the end of the presentation, maybe?
Yes, this is the end of the presentation. So these are some tutorials and references. And also, if you want to check more about performance in SQL statements, you can see the last part of the notebook. It has a lot of how to check performance of the queries. That's really important if you are running a lot of queries. But that's
also, Camilo, also we want to launch a poll, a very quick poll.
Oh, yeah.
So I will launch it now. You can continue.
Yeah, that's, oh, it's polling. It's polling. So, oh, it's moving really fast. Now we have 40 results, 50 results. $63.
Oh, meanwhile, maybe you can
70%.
answer.
Yeah,
Sorry, you can answer another question that
yeah, sure.
someone asked about if there is any entity relationship relation diagram that show all of the relations in the wiki of the database.
Yeah, we have one, but we want to make it public. I think we can add it to the notebook right now and send it to all the participants of the tutorial. But the idea is to have it public soon in the ALeRCE.science webpage. But we can add it right now for the tutorial.
Okay, thank you. I don't know if there is any other question.
So we have 91 votes of 108.
I think the other 17 are all hosts.
Yeah, perhaps we can stop it and share the results. I'll stop the poll.
Okay, so
Okay.
there are the results. So we have a lot of people that mostly everyone uses Python. Some uses Pandas. Half of them use SQL. And there are not a lot of people that use Google Colab. I think it's a really good result. I don't know if we can save it.
Yep, excellent.
Okay.
So I think we should stop here and continue at 4 p.m. and we can continue answering questions by the chat. So because the next session is also going to be intense. Thank you.
Thank you.